All right, so today, go to modules. You had worksheets that were due over the Labor Day weekend. I believe I gave you until last night to do it. So there is now a red circle with those items. So you're solving radicals. It technically is late, but you still have time to turn it in. You just get some points off, but you can still turn it in and it not be a 0. If you are still having issues with taking your picture and changing it to a PDF, guys, you all have this PDF candy right here, okay? PDF candy. It can, if you click on that, whatever file your picture is, if you're taking a picture on your phone, whether it is JPEG or what's next to JPEG? So JPEG to PDF. What else we got? We got all kinds of stuff. PNG to PDF, TIFF to PDF, bitmap. I mean, there's all kinds of files that you can load onto here and change them to a PDF. So you have to do that. You all have access to this free website. You have to change your pictures to PDF before you upload them. Okay? Have to. No exceptions. Do not email me pictures. Do not email me PDFs. Once you make it the PDF, you're going to upload it through Canvas. Okay? For today, we are doing section 1, topic 1, that is going to be in your notes. Okay? Today, I'm going to teach live. In the future, I'm going to connect the Algebra Nation video or a video that I personally make into this, so you will watch it and you will take notes. This first page has the notes here that you can print. Click next. You're going to have 2 things you have to upload. You're going to have to actually upload your notes, and you're going to have to upload the assignment. I need to see that you're actually taking notes. So here, I already have a video attached. That's going to go to the Algebra Nation website, which I'm about to show you. Okay, so I'm going to teach live, but if you need to go back, there's already an Algebra Nation video attached. And then I have the notes one more time attached for you to print or write on your own paper ahead of time. Okay. Nice. You are going to have to upload your notes. So you're going to have 2 assignments. Technically, one is uploading the notes that you have taken. And the second thing you're going to upload is your actual assignment worksheet. Okay. This is going to happen every day to make sure that you are taking notes and you are doing what you should be doing as a student. Okay. So here you will upload your notes. And then finally, this is going to be the actual assignment. This is the worksheet that you're going to complete after you have completed your notes. Okay, you will download this, complete this assignment, and then upload this. So each time we have a topic, you're going to upload 2 things. So on the days where you learn 2 different lessons, that means you're going to have 2 sets of notes to upload, and you're going to have 2 sets of assignments to upload. Okay, so make sure we are more than aware of how to upload assignments. You're going to have your first quiz next Wednesday. All right, so what we're doing up until then is going to be on your first quiz. So we're going to do the first 3 topics, and then we're going to quiz on them. All right, so I'm going to go through the notes first. I'm going to do it live with you today. I believe on Thursday, I'm going to upload a video for you to watch and learn from there, kind of like you did with your simplifying radicals last week. Okay. There we go. Download my notes. And these are always published in the morning, so you can always get this ahead of time. You don't have to wait until we actually meet to download your notes. These are the notes that we are about to go through together. All of this, okay? Notice it's a lot of word problems. So you're not going to want to write all this down if you don't have to. That's why I'm uploading the notes for you ahead of time for you to follow along. Okay, so we're going to start going through them together. Here we go. What we're doing is we are using expressions to represent real world situations. So our first example here says the Florida Turnpike is a 312-mile stretch of highway running from Central Florida to South Florida. Drivers who use a SunPass pay a discounted toll rates. For 2-axle passenger vehicles with a SunPass, the toll at the Orlando I-4 milepost is 53 cents. And the toll at the Okeechobee Plaza exit in West Palm Beach is $1.04. Okay, so this is all the information we're going to use to answer all of our questions. First question, part A. A 2-axle passenger vehicle with a SunPass drives through the Orlando milepost 5 times. Determine the amount of money that will be deducted from the vehicle's SunPass account. Okay, so it's referring to the Orlando milepost. So when I look at my information, the Orlando post costs 53 cents. So I know it's going to cost 53 cents. And then it told me that they drove through it 5 different times. So we're going to take 0.53. Instead of adding 0.535 times, we're going to multiply it by the number 5. Okay, so 0.53 times 5, I'm going to use my calculator. I know you guys have them too. So 0.53 times 5 is going to give me $2.65. So if I drive through the Orlando milepost 5 times, it's going to cost me $2.65. All right. Part B wants me to create an equation to show what's going to happen if I drive through the Orlando milepost any given number of drives. So right here, this sentence or this phrase, any given number of drives, that is your clue that there's going to be a variable because we don't know how many drives, okay? So let's create an expression and we're going to have to use a variable. I'm going to use, I don't know, how about X? Let's just keep it simple. Let's say X. So X is going to be the amount of drive-throughs through Orlando. Okay. So I know it's going to cost me 53 cents each time, but I don't know how many times. So the expression is going to be 0.53x. Okay. So with these problems, it's a two-parter. You have to define your variable and then you can use it in your expression. Someone's mic is on. Are you trying to ask me a question? Turn your mics off. Unless you're asking a question. We good? All right. Part C, the same car, so the same 2-axle passenger vehicle is going to drive through the other exit. I'm new to Florida, so I know I can't pronounce it. Okeechobee Plaza exit in West Palm Beach 7 times. Determine the total amount of money that will be deducted from the SunPass account. Okay, well, let's go back to the information that was given to me. Okay. So I have a different exit now, and which is going to cost me a different amount of money. So this time, it's $1.04 each time that we drive through this account. I mean this exit, excuse me. So $1.04. So it's $1.04 each time. Does it tell me how many times? It does, 7 different times. So we're going to multiply that by 7. So calculator. $1.04 times 7 is going to give me $7.28. So it will cost us, $7.28. There we go. To drive through this exit 7 times. All right, part D. create an algebraic expression to describe the total amount of money that will be deducted from this vehicle's SunPass account for any given number of drive-throughs of the plaza exit. Okay, so again, we have more drive-throughs, right? Could I use the same variable as last time? Well, technically no, because I might drive through the Orlando exit different number of times than I do the Okeechobee Plaza exit. So let's do a different variable. So I'm going to do Y for this one. But this is going to be drive through. There we go. Drive. There we go. Through. Oh gosh. I'm not going to write that word. Let's just say plaza exit. There we go. Okay. So we're doing a different variable because we might drive through the different toll booths different amounts of times. So I can't use the same variable. So this time, since we know we're using this exit, my toll is $1.04. And since it's any given number of drives, again, that's where my variable comes from, we're going to use Y for that one. Okay, any questions so far? No, you look good. Okay, going to move on. Part E, so same situation. Write an algebraic expression to describe the combined total amount of money that will be deducted from this vehicle's SunPass account after it passes through the Orlando milepost and the Okeechobee Plaza exit any given number of times. Okay, so some things I got to pay attention to. Algebraic expression means I'm going to be having my variables in it this time. We're going to have X's and Y's. Combined total of money. So combined means I'm going to add them together. That's a key word for us. All right, and we're passing through both different tolls and then any given number of times. So we know my variables are going to represent any given number of times, which I've already created. So we're going to do the Orlando expression, which we had 0.53x, and then we're going to combine it, or we're going to add it with the Okeechobee Plaza exit, which was $1.04 times however many times we drove through that. So that's the expression that combines the two tolls together. Okay. Part F, we're going to actually use this expression. So what's the total amount of money that will be deducted from the SunPass account after it goes through the Orlando exit 8 times and the Okeechobee Plaza 4 times? Okay, so my variables now have numbers. So the Orlando one, we're going through 8 times, and the Okeechobee exit, we're going through 4 times. So we're going to use the expression that we created in Part E. And now we have values to plug in for my X and my Y. So when I'm going to multiply 53 cents by 8, because we're driving through 8 times. And then we're going to multiply $1.04 4 times, because that's how many times we're driving through that one. I'm going to simplify each piece. So 0.53 times 8, that's my order of operations. I'm going to multiply first. So this gives me $4.24. And then $1.04 times 4 will give me $4.16. Now I'm going to add them together. And when I do, I get a total amount of combined money. It's going to be $8.40. So if I drive through Orlando, there will be a total of $8.40 taken out of my SunPass account. Okay, any questions? I'm gonna pause for a second before we go to our next example. That was the first example, lots of information, lots of stuff we could do with it. 1.04 came from the information in our very beginning description of our problem. So it came from right here. It told us that it came from $1.04 is what it costs to go through the plaza exit. Any other questions? No, we're good? Okay. All right, we're going to move on to our next example. All right. So we have Mario and Luigi. They plan to buy a Nintendo Switch for $299. Nintendo Switch games cost $59.99 each. They plan to purchase one console. That makes sense. You usually buy one console when you do. Write an algebraic expression to describe how much they will spend before sales tax based on purchasing the console and the number of games. Okay, so we know they're going to buy one console, which means they're going to spend $299. That is a given. They have to spend that much money to get the console. Okay, so there's the console. Now, number of games. Well, I don't know how many games they're going to buy, so let's use a variable to represent it. This time, I'm going to make my variable make sense. I'm going to use G. Let's say that G is going to equal the number of games that are purchased. Okay. So G is going to be number of games. If you wanted to still use X, you could, but you don't have to. So I'm going to add on to that $59.99 times G, because I don't know how many games they're going to buy. So algebraic expression, that's already giving us a hint. We're going to use a variable. We're purchasing a console, and we don't know the number of games. So we have to do $59.99 times G. So this is our algebraic expression for doing the console and the games. Okay, next. If they purchase one console and 3 games, how much will they spend before sales tax? Okay, so we're going to use the expression we just created. There's my console. Here's the price for however many games I buy, right? This time it told me we're going to buy 3 games. So I know that my G equals 3 this time. So this becomes $299 times $59.99 times 3, because we know we're buying 3 games. Oops. All right, let's solve. Order of operations tells me to multiply first. So 59.99 times the 3 games that we are going to buy. That is going to give me 179.97. And now order of operations tells me I can add those together. And we're going to get a total of $478.97. Okay. Remember, that was the price of one console and 3 games. All right, questions? I'm looking at the chat. I don't see any new questions. Okay. Let's continue with this information with the Nintendo Switch. Now Mario and Luigi want to purchase some extra controllers for their friends. Each controller costs $29.99. Use an algebraic expression to describe how much they will spend in total before sales tax based on purchasing the console, the number of games, and the number of extra controllers. Okay, so we have something new. So We know they're going to have the one console, right? We already know that G is my games. So we're going to use previous information. We already know they're going to spend $2.99 on the console, okay? We know that the games are $59.99, however many they buy. Now they're adding controllers on here. So let's do a new variable. Let's do C. So that's going to be how many controllers they buy. So we're going to do, and it's $29.99 for each extra controller that they buy. So here's a new algebraic expression. The first part is what we've already been using, right? We're adding on to it the price of extra controllers. What will be the total cost before sales tax if Mario and Luigi purchase one console, 3 games, and 2 extra controllers? Okay. So we have all the pieces together. So we're going to keep $2.99. We know games are $59.99 each. So I'm just bringing the expression from the past problem in here, and then $29.99 for the controllers. All right, so we have one console, we know that. We have 3 games, so my G equals 3. And now we have 2 extra controllers, so C is going to equal 2. So let's plug those in. So $2.99 plus $59.99 times 3 plus $29.99 times 2. Okay. Order of operations tells me to multiply first. So $2.99 stays. $59.99 times 3. We actually did that the last example, so we know that's $179.97. Now we're going to do $29.99 times 2 for the extra controllers to give us $59.98. And then now I can add them all together. And when I add them all together, we're going to get a total amount of $538.95. Like that. All right, questions. I'm going to pause for questions. Let's go back. Oh my gosh. I hate these touch screens. Do everything I don't want to do. Okay, so I might start making you guys show your camera when we do breaks like this for questions because it's too quiet. You should be having questions for me.
When is this due?
These are your notes right now. Your concern right now is to learn the material. So right now we're taking notes. You will upload these notes with your assignment today or tomorrow. All right, moving on. Study edge tip. When you are defining variables, choose variables that make sense to you. So like the one we just did, I used G for games and C for controllers because that made sense. Could you always use X and Y? Sure, you can. What letter you're using and what you're using it for. But it does make life a little bit easier if you can use variables that make sense to the actual problem, like H for hours and D for days. All right. Okay, so we're going to try one. The Thomas family likes to visit Everglades National Park, the largest tropical wilderness in the U.S. which partially covers the Miami-Dade, Monroe, and Collier counties in Florida. They hold an annual pass that costs $40. Each canoe rental costs $26, and each bicycle rental costs $15. Use an algebraic expression to describe how much they spend in a year based on the annual pass, the number of canoe rentals, and the number of bicycle rentals. Identify the parts of the expression by underlining the coefficients, circling the constants, and drawing a box around the variables. Okay, so here, we know that it's going to cost $40 for the annual pass. Okay, so right here, annual pass is $40. That's how much it is no matter what. Each canoe rental is $26. Since I don't know how many canoe rentals we're going to have, this is going to have a variable with it. So I'm going to say 26. Let's use C for canoe. Okay, so we have the canoe rental, and now we have a bicycle rental for $15. So again, I don't know how many bicycle rentals are going to have, so we're going to use a B for bicycle. Okay, so I have already created my algebraic expression. Now it wants me to do stuff to it. It wants me underlining the coefficients. Well, we have to remember what a coefficient is. That is the number that is attached to a variable. So here my coefficients are 26 and 15. Those are our rates. Circling a constant. Constant means it's never changing. So that's going to be the value that does not have a variable with it. 40 will always be 40. And drawing a box around the variables. Well, we decided to use C and B for our variables. All right, I'm almost done. We're going to keep going. Okay. Questions on what we did for just writing the expression and underlining, circling, all that stuff for different parts? No question? Okay, this is what we're going to do. We're at a break point. So I'm going to let you have lunch because I have to. So I will let you have lunch. We only have 3 more slides left. We don't have much to do. So we all need to come back here at 11 o'clock. Okay, 11 o'clock, you all need to come back. If you want to start on your assignment, you can start on it. But everyone come back at 11 so we can finish the notes together. Okay? So I will see everybody at 11. Go have lunch.